Now back to the mean. So you have a sample mean of 490 days. So is this small enough to believe that you're right and that the manufacturer is wrong? Or is this just a random sample fluctuation and mu really is 500 days? So how small does the sample mean need to be before we think that the claimed value of 500 days as a population mean is incorrect? So this is where the concept of unusually low and unusually high values from chapters 5 and 6 will come into play. So to have evidence that the mean lifetime of the batteries was less than claimed, we would need not only a sample mean that was smaller, or less than, 500, but it would need to be enough smaller than 500 to be considered an unusually low value. And to have evidence that the mean lifetime of the batteries was more than claimed, we would need not only a sample mean that was more than 500, but it would need to be enough larger than 500 to be considered an unusually high value. So in the last unit in probabilities, I was trying to help you make this connection between whenever we see unusual sample results, that it would lead us to believe that the claimed population parameter was not correct. And if we see an unusually high value, we think that parameter value has shifted to the right, that it's actually higher than they have claimed. And when we see an unusually low value, it means that we think we have evidence that the parameter has shifted to the left or is now lower than what was claimed. So in this case, you need to take the sample mean you computed from the data, and we want to find the probability of getting another sample mean less than or equal to it. Because again, we think that we're trying to show that we have something that's unusually low. So assuming for the moment that the manufacturer is correct, okay, so their claim of mu is 500, we're going to believe that until we have evidence that says otherwise. So the idea behind this is that you want to know what the chance is that you would have come up with a sample mean at least as extreme as the one you found if the population mean really is 500 days. So we assume they're telling the truth unless we have significant evidence to the contrary. So that means we want to find the probability that x bar is less than or equal to 490, given that, or assuming, that what they said is true. Which means we want to compute the probability of getting an x bar less than or equal to 490, given that mu is 500. So we have all the tools necessary to compute that probability because we learned how to do that in chapter 6. So to compute this probability, you need to know how the sample mean is distributed. So since the sample size is at least 30 and we were given a value of sigma, so these were our two conditions in the last section. We either needed a normal population or a sample of at least 30. And we were given this value of sigma. We know that the sample mean is approximately normally distributed by the central limit theorem for means, where the mean of that new distribution is still just mu, but the standard deviation of that new distribution is sigma over root n. So before calculating the probability, it's useful to see how many standard deviations away from the claimed population mean the sample mean actually was. So that gives us, we need a slightly different formula for the z-score here than we had in the previous chapter, because now we're dealing with the distribution of x bar instead of the distribution of x. And so the standard deviation is a little bit different. Okay, so in this case, we're going to take our z-score. We're going to see how far away our value of x bar is from the claimed value of mu. But then z-scores measure how many standard deviations fit into those gaps, so how many standard deviations away we are from a claim. And again, since we're dealing with x bar, our new standard deviation formula is sigma over root n. So in this case, we would get 490 minus 500. Okay, so we have a gap here of 10 days. Okay, we saw our observed mean was 10 days below what they claimed. But again, is that big or small? It depends on how variable the population data is, so we need the standard deviation, and it depends on how many batteries we looked at, the sample size. Okay, so if we plug those in there, we get about negative 2.19. Okay. So that means that this, so let's just put a little interpret here. So that tells us that this 490 is 2.19 standard deviations below the claimed mean. So our observed mean of 490 is 2.19 standard deviations below, since it came out negative, their claimed mean of 500.